This kit is called DTMF based robot, which is LGRB001. So the basic principle is that we have tried to make a robot which can be controlled by a DTMF device or a cell phone. So for this kit to work, first you need to connect a DTMF based device to this circuit, and then from your remote cell phone you need to give this device a call, and through which you can control the movement of this robot. So I'll just show you a demo of how this kit works. So I'll give a call to this particular cell phone from my remote cell phone. So once you've received the call, you can use your remote cell phone. For example, you can press the button 2, through which it runs in the forward direction. Keypad 5 is used to stop the robot. 8 is used to run the robot in reverse direction. From 4 it will turn in the left direction, and number 6 it will turn into right direction. This particular robot works on the principle of DTMF technology. So once you give the input from your remote cell phone, the DTMF device generates DTMF tones, which is received by this microcontroller, and it is a decoder. It is a DTMF decoder which converts the DTMF tones into binary signals, and the binary signals are provided to this microcontroller as an input, and this microcontroller converts those binary signals into output signal and commands the motor driver circuit, and then this motor driver circuit controls the movement of the robot. You can order this kit from our website www.kitsguru.com, where you'll find 2 versions of this kit. One is a complete working kit, and one is a breakdown kit. In a complete kit you will get a model of this robot and along with the entire circuit, and in the complete breakdown kit you will get all the components separately, which you'll have to solder with the help of our video tutorial, which is available at our website. In this section of the video, we will see what are the different components used in this kit, and how do we connect the components on the PCB, and how the components interact and work with each other, and how do we achieve the entire working kit? How do we convert the components into a working kit? Okay, so for that first we'll see what is the main PCB which is used in this circuit. So as you can see here, this is the main PCB used in the circuit. Now the PCB has 2 sides. The technology that we use on the PCB is called through-hole technology. So for that, first we'll take this kind of PCB. It has 2 sides to it. This is the top side where the components are placed, and then you have a bottom side which has a copper layer, and the tracks of the components are on the bottom side of the PCB. So we call it a through-hole technology because we drill holes from the top side throughout the PCB, so that we can connect each component, and then the soldering is done on the bottom side of the PCB. Okay, so I'll be explaining to you all the components corresponding to the ready-made kit that we have here. Okay, so this is the main PCB, and now we'll see what all are the components used in this kit and how do we connect them. So there are 3 sections to this kit on the main PCB. First is the power supply, the section of the power supply. The second is the section of the DTMF decoder IC, and the third one is the section of the microcontroller. And then we have another PCB which is a motor driver circuit. So we'll come to that later. So let us see the connections of the power supply. Okay, so first we have a power jack here to supply the AC input. Now this is a power jack, so this has to be connected to the PCB like this. Okay, then we have an on-off switch, as you can see here. So an on-off switch has 6 pins which has to be inserted in any direction. That does not matter. Okay, then we have a bridge rectifier. Now let me tell you something about the bridge rectifier. Bridge rectifier converts the AC supply into a DC supply. So it has 4 terminals to it, as you can see. One is a positive and a negative terminal, and the other one is a AC input signal. The positive and the negative is the output, DC output, and the AC signals represent the input. Now there are corresponding 4 pins beneath each terminal. So as you can observe, the pin with the positive terminal has a longest stem. Okay, so during the connection you have to ensure that the bridge rectifier is connected with the positive terminal diagonally right side opposite to you. So that means that the negative terminal will be facing you or closer to you. Okay, so here is the positive terminal. Okay, and then we have to insert a capacitor, electrolytic capacitor. Electrolytic capacitor is used to remove all the AC repulses which were produced during the rectification process. So this is an electrolytic capacitor. As you can see, even this has 2 stems to it. Now it has both positive and negative terminal. So the stem which is longer in length is the positive terminal, and if by chance if both the stems are of equal length, then there is this blue strip which has a negative sign onto it, which will tell you that this is the negative terminal. So during the connection in this kit, you have to ensure that the positive terminal of the bridge rectifier is in line with the positive terminal of the capacitor. So this is how we connect it. And then in order to supply a 12 volt power supply to the to the motor driver circuit, we have to insert a 2-pin connector. This 2-pin connector will ensure that 12 volt supply is directly supplied to the motor driver circuit. Okay, and then moving on to the next component, there is this L293D 7805 IC, which is a voltage regulator IC. So now what happens is the entire circuit and the microcontroller works at 5 volt. So we have to convert the 12 volt input into 5 volt supply. And we have to ensure that it is a smooth DC 5 volt input given to the microcontroller and the other components. So for that we use a 7805 voltage regulator IC. So if you keep the voltage regulator IC in front of you, you'll notice that the face which has the technical specifications written on it is the front side. Okay, and the stem which is on the leftmost side is the first stem, and then is the first terminal, then the terminal in the middle is the second one, and the rightmost terminal is the third terminal. Okay, so while connection, you have to make sure that the third terminal is pointing towards you. Okay, so this is how you connect the voltage regulator IC. Okay, then moving on to the next component. First we connect an IC 104, that is a capacitor which is 0.1 microfarad. The capacitor. Then we have to connect the resistors of 100 kilo ohm. As you can see, the two resistors here of 100 kilo ohm. So the resistors go here. Then we need to connect the crystal oscillator. Now there are two crystal oscillators used in this kit. One is a 3.5 megahertz crystal oscillator and the other one is a 10 megahertz. So the DTMF decoder IC has a 3.5 megahertz crystal oscillator, so which is connected here. This doesn't have any positive and negative terminal. You can connect it directly. Now a crystal oscillator decides at what particular frequency the microcontroller or the decoder IC works. So sometimes the oscillation does not start by itself. So for that we need to use two capacitors of 33 picofarad in order to start the oscillation process. Now since this is the section of DTMF decoder IC, we have to also insert a jack, a 2-pin connector jack for the sound input. So the 2-pin connector is connected here at this point. Okay, and then we'll connect the DTMF decoder IC. Now a DTMF decoder IC, which is an 18-pin IC, if you keep it in front of you, you will see that it has 18 pins and it has a notch to it. At this particular end, it has a notch to it. So if you keep it in front of you like this, here at the top right is pin number 1, and the number of pins have to be counted in counterclockwise direction. So the last pin at the bottom right is pin number 18. So this is the IC base. So first we will insert the IC base in the same way. The notch is on the right side, and so the IC base goes first. The IC base is used so that sometimes if the soldering does not happen properly, so in order to save the IC, in order to save the decoder IC, we use a base so that we can replace the base, or it may happen that in the future the IC gets spoiled or damaged, so we can easily replace the IC if we use an IC base. So the decoder IC fits onto the base. Okay, then we connect two LEDs. Okay, one LED is for the power supply, one is the power indicator LED, and the other one is for the sound input or the tone input. So let me tell you about the LED. Now the LED has two terminals, a positive and negative terminal. So the stem which is longer is a positive terminal, and the stem which is shorter is a negative terminal. Now sometimes if the stems are of equal length, you'll see that towards the bottom of the LED bulb, okay, on the negative stem there'll be a flat surface. Otherwise the LED is overall round, but you'll notice that the negative terminal has a flattened surface to it. So that indicates that it is a negative terminal. So the LED, both the LEDs will be connected in such a way that the positive terminal is towards you. Okay, so the LED, and along with the LED we also provide a resistor of 1 kilo ohm. Now this resistor is a protection. It protects the LED in case of a higher current. If a higher current is flows through the circuit, it basically protects this LED from blowing out. So we'll connect the next LED. So ensuring that the positive terminal is towards you, and we'll also connect the resistor. Okay. Now there is a couple of more components which has to be attached to the decoder IC. One is a 104 IC, which is a 0.1 microfarad capacitor. And a resistor which is 330 kilo ohm. So once you're done with the DTMF decoder section, we'll go towards the microcontroller section. So this is a 40-pin microcontroller, as you can see here. This is a 40-pin microcontroller. When you keep it in front of you, the notch is on the right side. So the right top right pin is number 1, and counting anti-clockwise, the bottom right is number 40. So while connecting the microcontroller and the IC base, you have to ensure that the notch is facing towards you, and insert the microcontroller. Onto the IC. Okay. So this microcontroller has a crystal oscillator which is 10 megahertz. So crystal oscillators goes here. This also doesn't have any particular direction, and to support the crystal oscillator you have 2 capacitors of 33 picofarad. We use a reset switch in order to reset the microcontroller. So the reset switch is inserted at this point. As you can see here, this is a reset switch. And to pull down the reset switch, we use a 10K resistor which goes at this position. And to pull down the port 1 of the microcontroller, we use 4 10K resistors. Now each resistor goes here in this position, like this. And to pull up the port 0 of the microcontroller, we use a network resistor. Now instead of using 8 different resistors, we use a network resistor to pull up the port 0 of the microcontroller. Now this is a network resistor. So when you keep it in front of you with the specifications written on the front, you will see a particular dot on the first pin. So while making the connection, you have to ensure that the dot is facing towards you. Okay, and then we attach the 4-pin terminal for the output of the microcontroller. Okay, so this is the basic connections of the main PCB. Okay, and you also have to ensure that as you go along connecting each component, you also have to ensure that you keep soldering each component. And for soldering purpose, we have another video that we have recorded, which will help you and which will guide you throughout the entire soldering, and it will help you how the exact soldering needs to be done. Okay, and how the connections needs to be taken care of without shorting any component. Okay, so once you have done this basic connection, we need to check, after the soldering process is run, we need to check whether the connections are correct and whether the components are working properly or not. For that, we'll use a multimeter. Okay, so this is the common terminal of the multimeter, which is connected to the common terminal of the voltage regulator IC. So we know that we have given an AC input supply. So the first terminal of the voltage regulator IC should show the AC input supply, so which is approximately 12 volts, but there's a drop due to the rectifier. Okay, and then we know that the output has to be 5 volts. So when we touch the third terminal, we get an output of 5 volts. Okay, and the signal at the microcontroller, the power input is checked at the last pin. So the pin number 18 of the DTMF decoder IC and pin number 40 of the microcontroller should show 5 volts. So this is more or less correct. Okay, so moving on to the next circuit. So this is the motor driver PCB. So as you can see, even this has two layers, the top side and the bottom side. Okay, so first we'll connect the voltage regulator IC. So this is the front end of the voltage regulator IC. So you have to connect it in such a way that pin 1 is towards you. Okay, and then 4-pin connector for the input, and then a 2-pin connector which is a power supply. Okay, and this is a symmetrical IC, the motor driving IC, which is L293D. This is a symmetrical IC, so you don't have to worry about the directions for this IC, and you can directly connect the IC with the base. Okay, so then you have two terminals to run the motors. Now this is a dual channel IC, so it means that you can run two motors simultaneously. So both the motors go on either side of the IC, and you'll also see that there are a couple of wires that we have taken on the board. Now sometimes what happens is we cannot create tracks at the bottom layer of the PCB, so we connect a few points from the top using wires. So we'll give you a separate piece of wire that you can attach. Okay, so now to check the connections at the motor driver circuit, you have to make sure that the 4-pins connector is connected to the 4-pin connector at the motor driver circuit. Now this doesn't have any particular direction. You can just connect it properly as shown here. Okay, now to provide the power supply, to check the power supply to the motor driver circuit, you have to be a bit careful. So 1 second, I'll just now first we'll have to check that which particular port is getting a positive signal. So we see that the port on the right is getting a positive signal. Okay, so this means that the voltage regulator IC here, the pin of the voltage regulator IC here should get high signal, which is 12 volts. So we have to connect the port on the right from the main PCB to the first pin of the motor driver circuit, so that this pin corresponds to this voltage regulator IC and it gets a 12 volt supply. And correspondingly, the third pin of the voltage regulator supply will give out a 5 volt IC, 5 volt output. Now this particular IC works on 5 volts, but the motors work on 12 volts. So we have to ensure that we give a 12 volt supply as well as a 5 volt supply from the voltage regulator IC. So that is why we have given both 12 volt supply as well as a 5 volt supply. So once you connect the 12 volt supply properly, so you'll see that the first pin is getting the AC input signal and the last pin is getting the desired 5 volt supply. And to check the connections of the microcontroller, if you check pin 1, it'll get a 5 volt reading, then 12 volts. Okay, so 5 volts here, then 12 volts here. So in order to check the entire circuit, we'll just have a test run. Once your circuit is complete, we'll see how it works. So if you press 2, it starts working in the forward direction. Press 5, it starts working in the reverse direction. Sorry, it stops at 5. Then if you press 8, it starts working in the reverse direction. And every time you input any tone, this LED starts blinking. So it means that it is receiving a signal. It is receiving a signal from the DTMF device. Okay. So in order to purchase this kit, you have to visit our website www.kitsguru.com, from where you can buy this entire kit, and also you will find a video tutorial for soldering and for other connections. And to find more products, you have to visit our website, and hope you enjoyed the video. Thank you.